We talk about differentiation by standard method. Then last time we talked about differentiation using the first principle method, and we followed the rules that guided the or that guides the first principle method for us to obtain our answer. Then we listed the rules and we followed them. Now today we want to talk about standard derivative of functions. Now this is the simplest way or simplest method of solving differentiation. Then as if you watch first principle method, you see that it is very long. The procedure is very long. Then and because it is very long, in a certain place you get confused. So that is why this standard derivative of function came to exist for you to do what? To solve that whole question with just how many lines? Let me just say 4, 5, 6 lines in your booklet. Then there are rules that guides it. Then when you want to talk about standard derivative of a function, then number one rule is that a constant in any function is always equals to 0 when differentiated. Then let's say it is dCdx. So is always equals to what? 0, which is a constant. So a constant in any function is always equals to 0 when differentiated. That is number one thing that has to go into your brain in order for you to solve any differential equation when given to you using the standard method. And this standard method is also equivalent. In short, it is the same thing with sum and difference rule. It is difference with different. Sorry, it is the same thing with sum and difference rule. Then in our subsequent class, we will talk about the rules that govern differentiation. Then for now, let's talk about when we want to differentiate a function that is not a constant. Then when you want to differentiate a constant, a number that is not a function that is not constant, let's say it is d, then we have a x raised to the power of n all over dx. So now when we want to find the change, it is always equal to n multiplied by a x raised to the power of n, then subtract 1 from the power. This is always what you will use in order for you to differentiate that function. Then you do it in each of the functions. Then any constant you meet in that function is always equals to 0. Then any function that is not equals to a constant is always differentiated using this. And what does this mean? This is a is a coefficient of x, then n is the power of x. What does this simply mean? You multiply the power of x by the coefficient and subtract the power by 1. Then when you subtract the power by 1, then you get your answer very straight. Then when you talk about exponent, when you differentiate an exponent in a function, an exponent, so it is always the same thing as what? Exponent, e raised to the power of x. So when you meet another this thing when you want to differentiate cos x, when you differentiate cos x, what will it give you? It will give you minus, it will also be minus sine x. When you differentiate it, when you differentiate cos x, it will give you minus sine x. But when you differentiate sine x, it will give you cos x. So that is how it is done in differentiation. Then let's solve this man. we have y is equals to 3x raised to the power of 3. Then how do we solve this? We say the dy dx of this man is equals to, remember the rule that says multiply the power by the coefficient, and the coefficient is 3. Then I subtract the power by 1. Then multiply the power, this is the power, then multiply the coefficient, which is 3, then x, then we raise to the power of 3, then and subtract the power by 1. Subtract the power by 1. And this is how it is written. Then where 3 is a, and we have our x, then n is 3. Then we subtract by 1. Then solving this now, we have it to be equal to 3 multiplied by 3 is 9. Then you have our x. 3 minus 1 is equals to what? 2. So our answer is equals to 9x raised to the power of 2. That is our answer. Then we go to the second one. Go to the second one that says y is equals to 4x raised to the power of 2 minus 7. Then we have the y dx of this function will give us 2 multiplied by 4. X raised to the power of 2 minus 1. Then minus 0. Where our constant is always equals to 0. Then in this now, we have it to be equals to 2 to 4 is 8. Then we have x. 2 minus 1 is 1. 1 raised to the power of x raised to the power of 1. Then minus 0. And it is equals to 8x. Anything raised to the power of 1 is always that number. I have 8x, then minus 0 is nothing. It's still minus 0. We scrap it out. Our answer becomes 8x. So this is how it is being solved when you use this standard derivative of solving differentiation. But when you use first principle method, it is very, very long, and you still arrive at the same answer. So depending on the question may direct you to use first principle method. Then you have to use first principle method to solve it. But if the question doesn't direct you to use first principle method, then you boycott it by using this method. Thank you so much for watching. Please subscribe to my YouTube channel, then hit the like button, then and follow me in my Facebook page. But thank you so much, and God bless you.